Hey guys, this is 3.2. We're going to talk about exponentials, mostly their graphs, their t-charts, and how to put them in the calculator, and then some random word problems about money. Okay, in the past, from college algebra, you know how to graph these things that have a tiny x squared on them. Things that have a tiny x squared on them look like a parabola. Hey, yeah. From college algebra, you probably might have seen it, but you don't for sure remember it. But x to the 3 power looks like a slippery snake. Later, we'll see that it's like the tangent or the cotangent curve. Okay, now in pre-cal, we're going to take this parabola and this, what we call a cubic, because it has a 3 in the air, and we're going to inverse them. And when you inverse exponents, and we are going to put the numbers in a different spot. So instead of x squared, now the number's in a different spot, and it's 2 to the x. Okay, and it's called an exponential because that letter x is in the air. That's why we call it an exponential. Okay. This hoopla underneath says that the big fat whole number looking thing is called the base. So on this number 1, the 3 is the base. It's the big thing. It's whatever we're sitting on. It's the base. It's like your butt. Okay. And then it says x is any real number. Well, I don't remember if you, on the last lesson, I said when you're starting out with the t-chart, you usually start out with like -1, 0, 1 or something like that. Yeah, we have a couple more. So I think maybe -2, yeah, I think that'll be it. -2, -1, 0, 1, 2. Uh-oh, I should do a couple more. How about -3 and 3? Okay. Now, when I'm going to take these x's and I'm going to plug them in, just like we did on the last section where we had an equation and we were looking for the t-chart. So we took some x values of -1, 0, 1, and we put them where the x was, and the number we got out is the y value. That's what we're about to do here. Okay, so I'm going to say 3 to the -2. Then big fat 3 to the -1. Then 3 to the 0. 3 to the 1. 3 to the 2. 3 to the -3. 3 to the 3. Okay. Now at this point, let's go ahead and practice putting this in our calculator, just in the blank screen. To get this 3 to the -2, we type 3, and then there's a caret. See this caret? It looks like a roof. Press that. Caret. And then some of you have a little box that goes in the air. Good job. The rest of us, we're just going to type -2. And it should give us a decimal. Press math, enter, enter. Yeah. Okay, so to get this, we're going to press 3, caret, -2, and then math, enter, enter. And you should get something crazy, like 1/9. Okay, and the reason that happens is because of exponent rules. Back in algebra, exponent rules said that if you had a negative exponent, to get rid of that exponent of a negative, you put it underneath a 1. So let's say I have x to the -12. That's the same thing. Let's say we have 5x to the -12. 5 stays on top because it does not have a negative exponent. But then whatever has a negative exponent goes to the bottom, and that exponent's now positive. Yeah, you send it to where it belongs. Okay, so let's see what this 3 to the negative 1 is? Well, we would still use the same buttons, 3, caret, negative 1, math, enter. But if we use what I just told you about whatever has the negative exponent goes to the bottom, this becomes 3 to the 1 on the bottom. And you might be thinking, what goes on top? Well, for this example, 5 went on the top because there was a big fat 5 right there. But the thing that's attached to our negative exponent is the 3. So that's why the 3 has to go to the bottom. But when there's nothing else sitting there, like this big fat 5, you put a 1 on top. So 1 over 3 to the 1 should just be 1/3. Okay, 3 to the 0 is 1 over 3 to the 0. But from algebra, 3 to the 0 is just 1. And so this just pops out 1. And if you're not that great with the arithmetic, that's okay. Just use your caret button in the calculator. But eventually, you're going to have to know all this stuff. Okay, then 3 to the 1, we know what that is. It's 3. 3 to the 2, we know what that is. 9. 3 to the 3, that's 27. Well, what's 3 to the negative 3 then? It's 1 over 3 to the 3, or 1 over 27. Okay, let's draw this. We need negative 2, 1 over 9. So let me go left 2, 1 over 9. Well, 1 tick up represents 3. So I can't really go up at all. Okay, then we have negative 1 and 1/3. So I can go left 1, but again, I can't really go up at all. Okay, then I have 0, 1. So that's 0 left and right, and just 1 up. Then we have 2, 9. So that's 2 to the right, up 9. Then 3, 27. And hey, this is an exponential. Yeah. So as you can see, it gets really high really fast. Our x values only change a couple of tick marks, but the y values jump so fast. It's because it's an exponential. And there's an asymptote right on this x-axis. And it's like a boundary of what we cannot cross. So this curve will only ever be in this top part of the graph. Okay, and this asymptote, it crosses through the y-axis. Do you see how it crosses through the y? It crosses, touching the y, touch the y. Okay, so that means it's going to be y equals, and wherever it levels off, or wherever that pretend imaginary boundary line is that the curve is not going to touch, that's where your asymptote is. Yeah. Okay, and usually your asymptote comes from the big fat number that's being added or subtracted after your problem. But if you look at us, we don't have a big fat number. It just says 3 to the x. It's kind of like saying 3 to the x plus 0. And that 0 is that asymptote. Yeah. Let's look at number 2. It doesn't have a big fat plus something, like a whole number. So it's like a plus 0. So this sucker should have an asymptote of 0 also. Let's check it. Okay, first, let me get my numbers I'm going to plug in. All right, now let me plug in those numbers. And this one's tricky because it says 2 to the negative x. So I'm going to say 2 to the negative, but then the x value is negative 3. What? That makes 2 to the positive 3. What? So let's go over that again. I take the 2, I raise it to the negative, but there's a dag darn negative 3 that I gotta plug in. And that makes just 2 to the regular 3. And 2 times 2 times 2, ocho. All right, let's plug in negative 2. 2 to the negative, negative 2. That makes 2 to the regular. Then 2 to the negative, negative 1. That makes just 2 to the regular 1. Okay, then 2 to the negative 0. Awkward. 0 has no label. He is nothing. So this just makes 2 to the 0 because 0 doesn't have a label of negative or positive. And then anything to the 0 is hot dog. Juan. So 2 to the 0 is 1. And then now let's plug in the rest of these numbers. And you think, oh my goodness, it's going to be so easy. They're positive. Let's see. We're plugging in a 1 into the negative x. So we're going to have 2 to the negative 1. Oh no. That means 1 over 2 to the 1. Because anything with a negative exponent, you throw it underneath. And this makes just 1/2. Okay. Then we have 2 to the negative, plug in your x value, 2. Throw it underneath a 1. 1 over 2 squared. Pops out 1 over 4. 3 to the negative 3. Pops out 1 over 27. Because don't forget it's 3 times 3 times 3. Okay, let's graph this. We have negative 3, ocho. So that's left 3 up, ocho. Negative 2, 4. Yeah, okay, it's something like this. Okay. And if you can tell, the curve is going to kind of level off, plateau right here at the bottom. Plateau means like a flat mountain. Yeah, it flattens. All right, and that's where the asymptote is. And it's still y equals, and it's still 0. And that 0 comes from this whole number that we added or subtracted. Okay, this first picture that we drew is called growth. Because it gets bigger faster. It's also called growth because that 3 is a positive. Its base was a positive. Okay, this second picture we have is called decay. Let's look at its equation and see why it might be decay. It's going down. Well, sorry, it's decay because we have a negative exponent. And our picture is going down from left to right. And this is the same, let's see, I think in algebra when we had lines that went this way, it was called increasing. And if we had lines that went this way, it went decreasing. So D, it all has the same D letter, decay, decreasing, declining. I'm doing that one. All right, here's that big fat whole number I'm talking to you about. See right there? All right, so let's go ahead and write down our x values. And we might have to do this in our calculator. Okay, this big fat whole number, that should be the asymptote. Not the whole number that's attached to the exponent, just the naked whole number. Okay, so first let's plug in negative 3 up in here. So we're going to have big fat 1 minus 2 to the negative 3 plus 1. That makes big fat 1 minus 2 to the negative 2. Because negative 3 plus 1 is negative 2. Then this makes 1 minus 1 over 2 to the 2. Or 1 minus 1 over 4. or 3 over 4. Okay, or we could put this in our calculator. We could say 1, 1, minus, 2, 2. How do I get that negative 3 up in the air? Use the caret. So use the caret, karate. Then negative 3 plus 1. Oh, hey, good looking 0.75. Yeah. Or I could plug in this whole thing into the y equals 1 minus 2 caret x plus 1. Let me try and find, where am I at? Okay, cool. Okay, negative 3 has 3, 4. Negative 2 is 0.5. Negative 1, 0. Okay, I think I got this all down. Okay, so we could either do the arithmetic, or we could just put it in our blank screen with that caret symbol, or we could put it in y equals. Okay, either way, if I graph this, oh, it's not very good. Okay, I think it looks kind of like that, maybe? Awkward. Okay, let's maybe press graph. Okay, good. All right, now there should be an asymptote where that mountain plateaus, where it levels off at the top. So let's go look for that asymptote. The asymptote should be y equals whatever the whole number was that's not attached to anything in the equation. So 1, y equals 1. Hey, asymptote. Okay. Now let's just talk about exponentials in general. Okay. We just figured out this asymptote hoopla was something cool. Yeah, this asymptote hoopla of like 1, it comes from this whole number, right? Yeah, okay. Okay, well, that whole number is what we call this big fat K. It's the plain whole number. And all this is saying that if I have a K bigger than 0, as in positive, my whole picture moves up. If I have a K that's less than 0, as in it's negative, my whole picture moves down. Whereas H is in the air. That's the number in the air. And as you see, if it's bigger than 0, my picture goes to the right. If it's left, the number in the air is smaller than 0. Okay, and then there's ways to stretch and shrink. Okay. Let's look at how to put a funky symbol in your calculator. The funky symbol we're going to use is this letter E. And E is a universal constant. It means it's a symbol. So universal constant means it's a symbol that means a number. It represents a number. Pi is like 3.14. Okay, well, E also has a meaning. It's like 2 point something. You don't care. Anyway, oh, here it is, 2.718, and it's called Euler's number, and we need him for money formulas. So that's why we're talking about this random E all of a sudden. Okay, so first it says evaluate round to 4 decimal places. Well, to get this E in the calculator, we're going to press second LN. And first we got to find the LN. First look for your number 7, or look for your number 4. Look for your number 4, and right next to it, it says LN. Above it, in blue, you see e to the x. So we're going to press the blue button at the very top left that says second, and then we're going to type that LN. So let's see what happens. I'm going to press second ln. And oh my goodness, an E popped up. Yeah. I think there's a couple of different ways you could do it, but that will for sure work. So we're just going to type e to the 2. I'm going to go ahead and do all these. E to the negative 3. E to the square root 7. Did I do them all? Oh gosh. Okay. E to the pi. Pi is right here on the caret button. It's blue, so you have to press the second, then the caret button to get it. Okay, and we're supposed to round to 4 decimal places. Okay, so for this first one, I got 7.38905. Okay, so 4 decimal places. That means here's 4 spots. The 5th is in 5 or more, so we got to up the score. So this is going to make 7.3891. Okay, for this e to the negative 3, it was 0.0497 with an 8 next to it. So we want 4 spots, and this 8 is 5 or more, so we got to up the score to 0.0498. The next sucker is 14.09403. 4 spots makes the 5th spot be a 3, and that's 4 or less, so we're going to let it rest at 14.0940, and you don't have to put that last O. The last sucker is 23.14069, but 4 spots tell us that that 9 is 5 or more, so we have to up the score to 23.1407. Yes! Okay, let's try and graph that e to the x plus 1. And for these, we're not going to try and do anything in our face. We're going to use lots of decimals. So it's okay that we're going to have decimals and not very much math. But we're going to look from negative 3 all the way to 3. And we're just going to type this in our calculator. We're going to go to y equals, and we're going to type second ln. That's to get the e up there. And then type x plus 1. So go to y equals second ln to get the e up there. Then put x plus 1. And let's go to our t-chart. So press second graph. And we should have all the decimals. We need to do it to 4 spots. I think that's what our calculator does already. Hallelujah. So we get, let's see, for negative 3, I got 0.1353. The next sucker is 0.3679. Then 1. Then 2.7183. Then 7.3891. Then 20.086. Then 54.598. Okay, let's see if we can graph this. So negative 3 is not very much above. Negative 2 is not very much above. Negative 1 is not very much above. 0 is 2 something. 1 is 7 something. 2 is 20 something. I guess it's somewhere up here. Okay. Okay. There we go. Hey. And as you can see, it's growth because it's going up from left to right. Our asymptote is that same big old whole number that is being plussed big and normal out to the side, and there is no number. That plus 1 is in the air, so that's not it. That's the left or right. So our asymptote is just 0. And my picture's kind of janky, but if we look at the calculator, it's better. Okay, let's look at the equations for money. This is for interest, like credit cards, house payments. You know, now anytime you want to buy something that costs a lot of money, you have to pay something called interest on it so that the company makes money off of you. Okay, yeah, so there's 3 different formulas we're going to use. Simple interest, where there's no exponents, and then these last 2 where there are exponents. So this first one is for simple. The next one is for something called compounding. And the last one is for called continuous compounding. All right,